So we talked about how in gases the particles are separated by large distances, a lot of empty space. Solids and liquids that we're focusing on in this chapter are what we call touchingly close. So they're close enough that they're touching or almost touching each other. They could reach out and touch someone. The difference between solids and liquids is the amount of freedom of movement that the particles have. In liquids, the atoms or molecules are touchingly close, but they're able to slide around relative to each other, whereas in a solid, the particles are fixed in position. They're vibrating, but they're not moving relative to each other. So here we have an illustration of that. Gas particles, there's essentially no interaction. They're just flying off in straight lines till they bounce into something. In a liquid, sliding around, mingling. So this is when we're out of class and everybody's off going their own directions and nobody really interacts at all. And here's liquid. This is like in lab where we're milling about, right? Interacting with each other but moving around. And this is in class right now where everybody's fixed in position. I'll go through some of these slides pretty quickly because I don't like reading slides to people. But just a reminder, gases have very low densities compared to liquids and solids. They have indefinite shape. They'll take on the shape and the volume of their container, and they can be compressed. This is because they have weak intermolecular forces. Liquids have higher densities. They have indefinite shape, though. They'll take on the shape of their container, and they have definite volume. The volume of a liquid will stay the same when you transfer it from one container to another. And all of these behaviors are due to moderate intermolecular forces. Solids have high densities compared to gases, but they're roughly the same as liquids. They have definite shape and definite volume. We can divide solids into two broad categories, crystalline and amorphous. So crystalline will have some repeating order to the particles, where amorphous will have a random or disordered. Amorphous means without shape. And we've got stronger intermolecular forces here. Liquids can assume the shape of the container because they can slide around and move relative to each other. In a solid like this iceberg, the particles are stuck in a fixed position, and so the shape remains the same. Any questions?